Okay friends, so let's start from where we stopped. So we are supposed to draw the line of symmetry here. The line of symmetry on the following figures. Okay, so first figure is a star. Can you tell me the line of symmetry? Will it be a standing line or will it be a sleeping line? Any idea? Yes, it will be a standing line like this. Yes. So as you can see, on both the sides of the star, on both the sides of the line, the star is the same. So hence this is a line of symmetry. Is that okay? But actually, you can draw many lines of symmetry to this. Frankly speaking, you can draw the line of symmetry like this also. So there can be many lines of symmetry. If you can see properly on both the sides of this line, the figure is the same. So yes, this can also be a line of symmetry. Like this, you can draw many lines of symmetry. But anyway, in the exam, it will be easy just to draw one or two lines of symmetry. Okay, so what about question 5? Is this symmetrical? Can I draw a line standing or sleeping so that on both the sides will it be the same? No, it is not symmetrical. No. Because even if you draw a line like this, it will not be symmetrical on both the sides. Even if you draw a line like this, not symmetrical on both the sides. So yes, so this is not symmetrical. Okay, so next, is this symmetrical? Question 6. Can I draw a line so that both the sides will be looking the same? No, I don't think so. If I cut it like this, if I fold it like this, will the figure overlap each other? No, it will not overlap each other. So there is no line of symmetry. But now see this figure out here, this side. Yes, this one. Is this symmetrical? Yes. Which line? Standing line or sleeping line? Any idea? Standing line, correct. Yes, very good, very good. So all of you are doing really good with respect to symmetry. So if I draw a standing line like this, it is symmetrical on both the sides. So yes, it is symmetrical. You can just write yes, symmetrical. Even here you can write yes, symmetrical. Easy? Okay, then let's go ahead. Let's solve more questions. Determine whether the dotted line is a line of symmetry for each figure, right? Yes or no? So if you fold on the dotted lines, will it be symmetrical? Okay, any idea? Question number 5. If I fold on the dotted lines, if I fold it, will this point, if I fold it, become this point? Is it like that? If I fold it with respect to that line of symmetry? No. This is not symmetrical. No. I can draw line of symmetry standing, I can draw line of symmetry sleeping, but this cross line is not the line of symmetry. Good. What about question 6? Can you see the moon, the nice moon, and they have drawn a line of symmetry as sleeping line? If I fold it, will it overlap? Yes, it will overlap. Yes. Very good. So the line is a correct line of symmetry. Now this is an interesting question. See this. Draw the other half of each symmetrical shape. So you have to draw the other half of the shape. So the figure is symmetrical. You just have to draw the other half of the shape. Okay. So how do you draw that? So you just have to draw the same shape, like the mirror image of the shape. So it is like this. I think it will go like this. And down it will go like this. And then you can join it like this. Let me draw this first. And then join. Okay. A little bit here and there, but yeah, this is how you can finish the figure. So if you see with respect to this line, both the sides are same. If you join them, they will overlap each other. Is that okay? What about this? This is a line of symmetry, and then here there is an object. So we draw the object on the other side also. A little bit smaller. And you have to draw the same object on the other side. It's very, very interesting to draw this. like this. So you can see the complete picture. It looks so nice, no? And then the line of symmetry, so that on both the sides it is the same. All right, let's go ahead. Let's go on to 3D shapes. So 3D shapes we have, there are many shapes in 3D. What do you mean by 3D? So 3 means 3 dimension. D means dimension. So something which has, if you can see here, something which has length, something which has width and a height. It's called a 3D object. For example, now this is a 3D object. It has a length, it has a width, it has this height. So this is a 3D object. It has 3 dimension. This is 3D. But now this is not 3D. If you can see, this is a simple paper. This is a paper. This is not a 3D object. This is simply 2D object. It has length and width. It doesn't have any height. Okay, so there is no height. So this is a 2D object. Okay, let's go ahead. So yes, exactly as I said, it has a length, it has a width, it has a height. Hence it is a 3-dimensional object. Okay, so what we need to know about 3-dimensional object, we need to know 3 words about the object. First thing, face. What is a face? Can you see this surface here? This surface here, the smooth surface where you can put your hand and move that? That is called a face of a 3D object. For example, if this is an object, it's a sanitizer. Nowadays we use a lot. If this is an object, then this is called a surface, a smooth surface on this. This is called a surface. Then next we need to know is an edge. What is an edge? Can you see this line at the corners? This line, then this line, and this line. These are called edges. Edges. So there are many edges. E, D, G, E, S. Edges. So if you talk about this bottle again, this is called edge. This corner is one edge. This is another edge. There are many edges. We have to count the number of edges in exam. Okay. We have to count the number of edges. And then the last is vertex. Vertex. What is a vertex? Is this point, the corner points. The corner points are called vertex. So we have to count how many vertices are there in this figure. So first thing we should know is the face, the smooth surface. Second thing we should know the edges, which is the lines at the corners, all the lines. And the third thing which we should know is these points which are called vertex, and plural vertices. Okay, fine. If so, we understood face, we understood edge, we understood vertex. Now you have to tell me in this figure, 3D figure, how many edges are there, how many faces are there, how many vertices are there. Before that, this figure, this rectangular box is called rectangular prism. You should know this properly, that this is called rectangular prism. Okay, so this is a rectangular prism. Tell me, how many surfaces, how many faces it has? Any guess? We learned this in the class, so you should know this. How many faces? 6 faces. Correct. Very good, everybody. Really good. You know that. How many edges it has? How many edges? We can count how many edges. It's okay. See, 1, 2, 3, 4. Then on this side, on the left side, 5, 6, 7, 8. That's 8 vertex, 8 edges. Now 9, 10, the big ones, 11, and this back side 12. So there are 12 edges. How many vertices it has? How many vertices? How many points can you see? Let's see. Let's check it out. 1, 2, 3, 4. واحد اثنين ثلاثة أربعة. Then 5, 6, 7, 8. 5, 6, 7 and 8. So number of vertices are 8. Are all the faces of the same size? Are all the faces same? No. Some are small, some are big. So are all the faces same? No. The answer is no. Can you see this no? Yes? Good. Let's talk about a triangular prism. This is called a triangular prism because it is triangle in shape. Can you see this triangle in shape? So it's called a triangular prism. It has how many faces? 5 faces. One triangular this side, 2, 3 at the back, 4 here, and 5 at the bottom. So there are 5 faces. 9 edges. You can count the 9 edges. 1, 2, 3, 4, 5, 6, 7. This big one 8, and this big one 9. So there are 9 edges, and vertices are simple. You can see the vertices are 6, so it's very easy to understand the vertices. Now let's come on to the last part of this chapter 12, geometry. That's volume. What is the volume? Can you see a rectangular prism here? Yes. Can you see rectangular prism? Yes. What is volume? Volume is the amount of space inside this. The amount of space inside this is called volume. Volume. So what you can do, you can put water inside this box. You can put water. How much water you can put inside the box? It is called its volume. Okay. So we have to find the volume of some rectangular prisms. Let's find it. First, we'll see the formula for the volume. The formula for the volume is length multiply with width multiply with height. So they will give you the length, they will give you the width, and they will give you the height. You just have to multiply them. And you have to multiply using your brain, not using calculator. Okay? Good. For example, see this rectangular prism. What is the length of the rectangular prism? What is the length? 6 centimeter. So this is the length of the rectangle. I write it as L. What is the width? The width, this is the width, which is 2. And this is the height, which is 3. So the volume of this will be 6 multiply 2 multiply 3. Very simple. What is 6 multiply 2? Come on, 6 multiply 2. 6 multiply 2 is 12. Multiply 3. 12 multiply 3 is how much? 12. 12 plus 12, 24. 24 plus 12, 36. So the answer is 36. The answer is 36. But you write centimeter cube. Centimeter cube. So always volume will be something cube. Centimeter cube, meter cube, like that. Let's see this example. There are many layers to this box. If you see the layer 1, the smallest layer here, the smallest layer, okay, what is the length of this layer? The length of this layer is 1, 2, 3, 4, 5, 6. The length of the layer is 6. What is the width? The width, count the box, 1, 2, 3. The width is 3. And what is the height? The height is just 1. So the number of cubes will be the volume basically. You can just count the number of cubes, or you can find the volume. What is the volume? Length multiply width multiply height. So 6 multiply 3, 18. 18 multiply 1 is 18. So the volume is 18 cubic centimeter. You write centimeter cube, or you can write 18 here. Like that, you can count for all the boxes and finish it as a homework. Okay, we did this in the class, so I'm giving it for homework. Let's do this again. Rectangular prism. What is the length? The length of this box is 11. The width is 7 and the height is 9. So 11 multiply 7 is 77 multiply 9. So 9 times 7, 63, carries 6, again 63, so 693. Easy? Just multiply them. Again for this one, which you are seeing here. The base area is 24, it is given. So just multiply 24 with 12. So you get 24 by 240 and 48. So 288 meter cube, because this is given in meter and this was given in millimeter. Okay? I hope you understood the volume. All the best. See you in the next video.